Hello everyone, in this video we are going to see about how to design the conventional components. We all know that component is a basic building block for a computer software. The computer software is always done in a modular fashion. That means we have many modules so that we can develop a complete software. So every module is called as a component. It has higher level of abstractions defined by the interfaces. It helps in achieving the objectives and requirements of the system to be built. So components collectively have they individually have some functionalities, and they collectively does the functionality for the whole system. Now let us see the conventional design constructs. These conventional design constructs emphasize the maintainability of a functional procedural program. That means you are having the sequence, condition and repetition. Normally we have the continuous flow of instructions, which is called sequence, and then we can go for the processing based on some condition like if, else, case statement and all those things, and repetition, which is all about the loops, for loop, while loop and the do loop. Each construct has a predictable logic structure where control enters at the top and exits at the bottom, enabling a maintainer to easily follow the procedural flow. So here normally the program starts from the top level, and it execute the programs the execution instructions one by one, and it will come to the end and it will exit at the bottom. So that is the normal procedural flow. Various notations depict the use of these constructs. So what are all the various notations we are using in this constructors? Graphical design notation we are using for sequence, that is the continuous statements, then if then else statements, selection statements and the repetition statement. And then tabular design notation, here we are using a tabular column of information to design the conventional components. And next one is the program design language, which is similar to a programming language but is like a pseudocode. It is a narrative text embedded directly within the program statements. Now let us see the picture for the graphical design notation. So this is the sequence. It starts from the top and it goes one by one and it follows and it will exit at the end. This is the sequential flow. We have all seen this in the flow chart also. The flow starts from the top and goes down the bottom. Next one is the if then construct, which is a selection structure. This is the actual condition structure. So if condition is true, it will go to one branch. If it is false, it will go to the other branch, and then finally it will come back to the common branch. So that is the if then else, which is an condition checking. Next one is the selection. We have many options to follow. This is the example of a case statement. So based upon the case values, if it is true, the particular block will be followed. If it is false, next will be done, and if it is false, next will be done, and finally the default will be executed. That is the example of a case statement. That is the selection. Selecting one among the many, that is the selection statement. And then finally the repetition. This repetition, we have all the while loop, for loop and the do loop for doing some process repetitively in a programming language. Let us see how with an example how this program notation is used to define this particular code of instruction. So we can see the function points are mentioned over here. Now we can see then statement 1 and 2 are just they are the declaration function and the open brace. So now we can see the function starts at 3. So this is the third, the 3 is mentioned over here, and then the loop starts from the 4th line. So the 4 is mentioned here, and then the loop is actually, we can see here the numbers are missing. After 10 it is 11, 12, 13, 14, etc. So we can see here the while loop starts from 4th line and it ends in the 19th line. That we can see over here, and it will come back to the 20th line is the return statement, 21st is the return statement. So you can see here the loop, it starts from the 4th statement, and it will in between there are many statements available. There are if statements and else statements are there, but the while loop that starts from the 4th line and it comes to the 18th line, it is printing the value, and 19th line it is a dummy statement, that is the close brace, and the 20th statement it will come to the end of the program. So we can see the program loop goes this way, the while loop goes, this is the path of the while loop. Okay, then now after that it goes the normal execution, which is the sequence here. So after 20, the 21, which is return statement over here, and then it goes on and on with the remaining statements in a sequential fashion. And now let us come to the inner part of this graphical notation, where line 6, actually what is 6? 6 is one of the if statement, and then this if statement has some branch with the else if is there. So you can see this is the 12th line, is actually 12th line, it is else if. So you can see here from the 6th we are having the communication to the else if 12th statement, and then from 12th it will go to the, it's a linear thing, it will go to the second statement, because it is if condition is if x modulo 7 is equal to 0 or, so this comes in parallel line. So we can see the difference, how if it is an, if the statement belongs to the same line, it comes in the straight path like this. If it is a branch, it goes down the picture, and if it is a communication between, that is the, it's a starting and the end of the loop, it goes like this. So this pictorial representation helps to represent the flow of the program. And you can see from here, from 12, that is the else if statement, the line goes to 15. What is 15? Actually printf statement. Else is one particular statement with the, which having all these constructs, and then just go to the 15th statement, and then 16 is the next statement after the else if statement. So it goes in the sequence. Then after 16th it will go to the 18, because end else is the end of the loop, it goes to 18. Likewise you can see here, and from this side you can see after 7 it is 9 and 10 in sequence. Actually what is 7? 7 is the condition checking statement, and 8 is the normal open brace, so it is not considered, and then it goes to next statement, which is the printf statement, which is 9, and 10 is the increment operator. So they are in the sequential level. So the diagram actually what is represent is, wherever the sequence of instruction comes, it is goes like this one by one as in sequence. If any branch comes, it goes like this way, if and else branch, and then if anything parallel line comes, it is given in the same level, and if any loop comes, it is given to the end of the loop as an a circular fashion. So this is the way the graphical notation helps to represent the code in a module. Next is the tabular design notation. So what is this? What does this do is, it lists all the actions and lists all the conditions, and also it lists all the rules. So based on the rules, the actions and the conditions, so the rule is tested, and then specific condition is tested, and if the condition is true, the decisions are made accordingly, it is true or false, and then it will check for associated specific sets of conditions with the specific actions, eliminating the impossible combination of the conditions. So everything is done in the after the condition is executed or the decision is made. Okay, so this is the tabular design notation, which helps to make actions in the programming code. Let us see the tabular column notation. When you have more number of conditions, it is hard to follow the path. So we all used to use the tabular column in order to make a clear rule, and it's how to follow this. So you can see here, conditions are A, B and C, actions are X, Y and Z, rules are 1, 2, 3 and 4. So now this way we have made a tabular column, and then we can say if condition A is satisfied, the rule says that if it is true, if condition A is true, and then the action X is taken. Okay, and then if condition A in the second rule says that if the condition A is true and condition B is false, we have to take the action as Z. And likewise you can see in the fourth column, if the condition A is false and condition C is true, the action has to take place is action Y and action Z. You can see here action Y column, it is a tick is given, and action Z column, a tick is given. So this way we have to infer the tabular notation. So this is the way the program logic is mentioned as an tabular design notation format. Now let us see about the program definition language, which is then pseudocode. A pseudocode is an artificial or informal language that helps the programmers develop the algorithms. So you know that what is an algorithm? Algorithm is a sequential step of instructions to follow to do some task, to achieve some task. So those algorithms are normally written in an English language where we can communicate with the others to follow the instructions. And what is pseudocode? Is some type of code. It is not actually a code, it is a pseudocode. That means the codings are not perfectly implemented or presented, but only a part of the code is mentioned. So that is the concept of the pseudocode. The pseudocode is a text-based detailed algorithmical design tool. The rules of pseudocode are reasonably straightforward. All statements showing the dependency are to be indented. What is indented is giving the spaces. So the space says that the code that comes in the same line or the same level, that are the dependent statement, and the statements that comes little bit away or towards, so that they are all the statements belongs to different blocks. So that is the meaning of this indentation in the pseudocode. Now let us see the example. You'll understand how the pseudocode works. So a scenario is given. Consider the problem of reading a record from the file. If the file reading is not completed and there is no error in the record, then the print information of the record. Otherwise, print that there is an information error while reading the record. So this is the process. Actually, what is the process? Given a file to read, and we have to see that the printing is done if we are able to read the record from the file. If you are not able to read the record from the file, you have to say there is an error. That is the process. So how to mention this process as an pseudocode? Let us see. Process F procedure. We are giving the name of the procedure as F procedure because it is a file. We are giving an prefix as F, and then the process. So what is the process here? Read the file. While not end of file. Normally when you want to read the file, we always check till we are reading till the end of the file. We always have an end of file marker called EOF. So every file is read till the end of the file is come. Actually, it is end of file. Okay, there is a typing mistake. Is the end of file. And then if record okay, then okay. So now if the record is okay, means that means if you are able to fetch the record, then what you have to do? Print the record. Okay, and then else, that means we are not able to fetch the record, you have to print the error. Okay, and now else if, what you have to do? You have to say that read the file, and then you have to use the end while. Now we can see the indentation here. Here what is indentation is while has the end while in the same line of code, and then if, else and else if, they all have the same, they are in the same level, they are typed in the from the same indentation. And within if is print record, within else is print error. This is actually print, okay, print error. So here, so we can see that one space it is just shifted. So what does it mean is this indentation says that the statements that comes on the same line belong to the same block, which is just typed to the left, which inside that is the next block that comes under the previous block. So the indentation gives some meaning in this pseudocode. So this is how to represent this scenario as a pseudocode. And the process has to end. We are giving an end statement. Okay, so to implement this, it has to be converted into a programming language statement. So this is a normal statement with the communication language English to communicate with the user or the designer. But now in order to implement it, we have to use the specific programming language. We all know that every programming language has its own construct, its syntax, its regulations, its rules and its semantics to follow. So if you are implementing in Java, follow the syntax in Java. If you are going to implement in C or C++, so follow the syntax of the languages respectively in order to get the code done. So that are all the three different conventional notations we have seen in this video. So they are all the graphical design notation, tabular form, and as well as the pseudocode. And thanks for watching.